All right, so now on to my favorite subject, which is supermarket refrigeration and parallel rack systems. First of all, let me qualify this chapter by this just scratches the surface of supermarket refrigeration to get you familiar with it. If you go back and review the chapter on controls and different refrigeration components, and you understand the refrigeration cycle, you'll discover that the rack systems, while they are intimidating when you first see them, they still operate on the same principles of basic refrigeration. It's just that they do it a little bit differently. The biggest thing that most of us have and had problems with are the controls, because they're very control oriented, and it is extremely complex with the controls. But those you can learn individually. So, for example, if you work for a company that works at the Winn-Dixies or Publix or whatever the case may be, they usually all have the same controls, and you'll learn those controls as you go. You will never be sent out on a supermarket refrigeration call on your first service call, so don't worry about that. But learning objectives, just so we can cover those quickly. A little bit about product visibility and customer access, multiple refrigerated cases and temperatures, parallel rack systems, controls and controllers, mechanical subcooling, airflow, installation, service, and maintenance. Again, this is just scratching the surface, and new technology. Okay, so if you walk in, next time you walk into the supermarket, you'll notice that there's produce and deli, meat, frozen juice, frozen food, and ice cream. And even in some of the meat cutting areas are refrigerated also to keep the humidity down. So how do you do this how do you have all of these different temperatures in the supermarket and not have tons and tons of machinery? And that's because we use parallel rack systems. Um, it is one bank of compressors with controls and a header that it will serve all of the different temperature cases. Um, they share a common source of refrigerant, so they all share refrigerant, and they all share the same oil. Here's an example of a parallel rack system. This is a very small system right here. This would be for a very small mom and pop grocery store. If you get into the bigger supermarket chains, you will see systems that have compressors that are much larger, and there may be 20 of these lined up with a big header here, and they may be stacked too high. So it's very interesting. You'll notice here that this is the controller, different types of compressors. I see a lot of and saw a lot of Carlisle, oil pressure controls, oil separator, and the liquid level indicator on the receiver. So it's got about everything that you can imagine refrigeration control wise, and it's all on a great big rack up in the upper floors of the supermarket. Okay, now we're going to take a look at a illustration of a basic parallel rack system minus controls and a lot of the components, but it's got the basics here. And this is an illustration of what we just took a look at. So let's walk through this a bit. So here are the compressors that we talked about, 1, 2, 3, and 4. Here's our discharge header. So they all discharge that hot compressed gas into the discharge header. And then we have our oil separator here. So what happens is our hot gas goes in here and the oil falls out and is separated from the discharge gas, so it can be kept close to the compressors, and it's not circulating out through the system where it isn't needed. So it leaves the oil separator, it goes out to the condensing coil. The condensing coil setups are different depending on the system. In Montana, the grocery store that we used to work at, in the wintertime would send the hot gas to a huge condensing coil in a, actually basically it was a fan room, and it heated the entire store using the heat from the condensed gas through that coil. They didn't even have rooftop heaters up there because it reclaimed all the heat from the refrigeration cycle. Anyway, so it goes through the condensing system, and then we have our uh, condensed refrigerant liquid, 100% liquid, comes into the receiver, goes through a huge liquid line filter dryer, and then it goes out. And then it goes out to, let's say, for example, produce, and it goes to the evaporator coil in produce. It has its own TXV here. And then we have line number 2 may go out to the ice cream machine, which is at different pressures and temperatures, different TXV, and it services each one of those different refrigerated areas in the supermarket. Then they have their suction lines come back to the common suction header here. And that's basically how the a rack system works. And then the pressures are controlled by using the evaporator pressure regulators, EPR valves, on each one of the suction headers to control the different suction pressures needed for the different refrigeration temperatures. And that's pretty much how it works. And if you look at it, the refrigeration cycle works exactly the same, a few more components, a few more controls, but if you break it down into each individual system, it is discharge pressures and subcooling and superheat and TXVs and coils and everything else that we're used to. So don't get too intimidated by it, just kind of get your head wrapped around it.